Now let's talk about the trigonometric form for the complex conjugates. So we have the a plus bi equal to r times cosine theta plus I times sine theta. And here a is equal to r times cosine theta and b is equal to r times sine theta. So the conjugate of this a plus bi is equal to a minus bi, right? Now you plug in them into here, you have the r times cosine theta minus I times r times sine theta. Now you factor out this r, you have r times cosine theta minus I times sine theta. Is this the trigonometric form for this conjugate? Yes or no? You know, if you have the trigonometric form, there should be the cosine theta plus I times sine theta, right? And right now here we have the minus. So this guy is not the trigonometric form for this conjugate. To get the trigonometric form, we need to use these two facts. First, we know cosine is even function, so cosine of the negative theta is equal to cosine theta. And the sine is odd function, so negative sine theta is equal to sine of the negative theta. Then, now we can rewrite this conjugate a minus bi, which is equal to r times, let's replace this cosine theta by the cosine of the negative theta. And let's replace this I, this negative sine theta by sine of the negative theta. So you have the I times sine of the negative theta. And then in this way, you get the conjugate. So that means to get the conjugate, to get the trigonometric form of the conjugate of a complex number, you may just negate the argument, right, and keep the modulus. Let's look at the 64. Find the conjugate of this number in the trigonometric form. So we have the root of 2 times cosine of the pi over 8 and plus I times sine of the pi over 8. So this is the a plus bi. Then the conjugate a minus bi, we know we just need to negate this argument. So root of 2 times cosine of the negative pi over 8 and plus I times sine of the negative pi over 8. Now let's look at the 69. We need to find the product of the given complex number and its complex conjugate in trigonometric form. So the complex number is the 2 times cosine of 7 degrees plus I times sine of the 7 degrees. And its conjugate is equal to 2 times cosine of the negative sine, 7 degrees plus I times sine of the negative 7 degrees. Now you multiply this 2, so you have the 2 times cosine of 7 degrees plus I times sine degrees, sine of the 7 degrees, and then times 2 times cosine of the negative 7 degrees and plus I times sine of the negative 7 degrees. So we first multiply the moduli, 2 times 2, you have the 4. And then you add the arguments. So it's 7 degrees minus the 7 degrees and plus I times the sine of the 7 degrees minus 7 degrees. So we know the cosine of 0 is equal to 1. Sine of 0 is equal to 0. So finally you have the 4. Then done.